Hello and welcome back to Research Methods. I'm your instructor, Dr. Gabriel Science, and this week we'll be taking a look at sampling and generalizability. In this fifth week of the course, we're going to work on understanding how we can deal with the fact that we will never gather data from the entire human race, but that's okay. We can use probability and statistics to make intelligent judgments based off of what we can gather, the data that we can observe, that can work for larger and larger groups of people, as well as what rules we have to follow to make that happen. The sections in this chapter are first are populations and samples, so kind of an overview of what I just mentioned. Next, probability and significance, how we take samples of people and turn that using probability into meaningful statements about the most of the world. Uh, Dr. Hobo is playing bullets per minute. Awesome. Next up, sample size. Sample size is what how we call the number of people that we observe in a given research or study, and how we choose how many people is enough, or how much data is enough to make a generalized statement. Finally, we'll take a look at setting up a Google survey. This will be kind of the first step to starting your research paper for this semester. You will have already ideally put together a research proposal and received feedback on the research proposal. So the Google survey should be a small step in the next in the right direction to getting that research paper written up. A small step, but a very important step, and you'll be using most of what you already know to make that step happen. So let's get started on this first section, populations and samples. First, let's define terms. Population, or a population, is the group of all of the people that you are interested in doing research on. Say, for example, you want to know whether high school boys and girls tend to be able to jump higher, one higher than the other. In that case, you're probably going to be looking at a population of high school boys and girls. Now, there's a couple things that you have to be careful about. So, are you only looking at high school boys and girls in the United States? Are you looking at them within a certain state? Are you looking at them within a region of the United States? Are alternative high school students acceptable? People who take high school classes at home. Are people from any high school in the world acceptable? Are you only going to be looking at boys and girls? And what do you mean by boys and girls? So are people with a transgender or another gender condition qualified here? Are you working with people of the specifically sex? Uh, so male and female, or gender, self-identified male or female. So it, there is no perfect correct answer for the population you're looking at. In fact, it's always going to be your choice. What group of people are you interested in understanding better? Now, you could have an incredibly specific population or an incredibly broad population. It's important that you are aware of what that population is so that you know the extent of your generalizability or the limitations that you have to place off of the statements that you conclude from your data. Sample, on the other hand, is going to be the people that you actually gather data from. There's no way that you could gather jumping data from every single high school student in the nation. There's probably no way you could gather jumping data from every high school student in your state. So you're going to have to pick high school students in some way. You could do that in a lot of different ways, but the way in which you pick your sample is important because that affects how well you can generalize your statement to all high school students. So, out of the high school students in the entire world, you may choose to just gather data from students in Missouri, and even that might be too much. So you may choose to just gather data from students in your own local high school classroom. And if you do that, it's important to be aware that there are people in your population in each one of those sections, and that really your sample is a subset of each one of those subsections of people. But that based off of the data you gather from your sample, you're going to try and generalize to the rest of your population using statistical analysis. Now, there are some things you want to be careful about when you pick your sample. First and foremost, that your sample should accurately represent your population. There's a couple of different ways or reasons that you're going to do that, but obviously the most important reason is for external validity. We learned about that in the last module, that meaning how well can you say that the data or your research maps on to the people that you intended to look at. Let me give you an example of sampling and populations. So let's say you work at the Fudgy Pop factory where you make ice cream pops that are covered in fudge. And you want to make sure that the quality of your Fudgy Pops is great. So how can you do that? Well, realistically, the only way that you know that all of your fudge pops are great is to taste every single fudge pop. But that's kind of dumb. There's no way you can do that because you have to sell some of them, right? So we have to pick a sample. Now, how do we ensure that the sample makes sense for the population? You could grab one fudge pop, say the first one that comes off of the assembly line, and taste it. And if it tastes good, you could say that, well, maybe probably most of the fudge pops taste good. But is that a valid assumption? Can we say that the first fudge pop is a good sample of the rest of them? And how many fudge pops do we need to try? Let's think about this in terms of the bias of your sample. You probably want to pick a random set of fudge pops off the line and taste each one of them, and then you could probably say that since you picked them randomly, that all of the fudge pops are reasonably well represented. Well, let's take a look at a situation where you may not necessarily pick fudge pops randomly. So in this case, you want to learn whether or not the students in your high school want to improve the football stadium or buy more band instruments. So how should we spend this money? Football stadium, band instruments. And so you gather data from a sample of people. The sample of people you gather is you survey the cheerleaders and ask them, should we improve the football stadium or buy band instruments? Now, because the cheerleaders are probably going to be more involved with the football stadium than with the band instruments, you haven't really picked a very good sample of people. Yes, the cheerleaders are high school students, but it's a biased sample because you're not representing your average high school student. You are more representing the students involved with the football stadium. An unbiased sample might be to gather a couple of students from every table at lunchtime. The reason that's more unbiased is because every student in the school has a even chance to be picked, and because there's an even chance of picking students involved with football or students involved with band instruments. So it's important to be careful of biased samples and try to make sure that your sample that you gather is unbiased. Let's take a look at another example of potential bias. If you've ever done a survey to rate your professor or your college instructor, you may have some questions about the survey. So there are websites that allow you to say your opinion about your professors or your instructors. So think about this. Does the survey that these websites offer, does this data consist of biased or unbiased data? Well, let's think about this. Why would a student complete a survey? They might complete the survey because they really enjoyed the class or because they really hated the class. They might complete the survey because the class was really easy or really hard. They might complete the survey because the instructor asked them to complete the survey or just because they always complete the survey. There are many, many different reasons why people might complete these surveys, but one thing you can be sure of is that every student is not given a random and equal chance to be selected to complete the survey. So this actually does a pretty good job of exemplifying things that can make your sample more or less biased. Self-selection is number one on the list. If people choose to participate in your study or in your data, there's a chance that something about those people will affect your data. So if people choose to respond to a survey about the instructors, maybe they really liked the instructor. An unusual selection of people might be anything that could affect your results. Say you pick the first 5 people who leave on the last day of class. Maybe that was your final, and those 5 people probably finished the test because they did really, really well. or maybe because they didn't care and just turned in a blank paper. An exit poll sample is an interesting way to pick your participants. What I just described is kind of an exit poll sample, but you don't want to just pick the first 5 people. A better way to do that would be to pick, say, maybe flip a coin, and if it's heads, then you pick that person. If it's tails, you pick the next person, and so you randomly select the people coming out. So what can we do to make sure our samples are unbiased? You've probably picked it up on it already. We're really going to rely on randomness. Let's break down the types of samples that you can get. So if you randomly pick the people who participate in your research study, then you are coming up with a simple random sample. That means that you've randomly selected your participants, ensuring that everyone has an equal chance. You can do this by picking names out of a hat. You could do it by picking, if you just wanted to survey everyone in your high school, you could grab your high school phone book and just randomly select names. Polling companies use random phone numbers, but even then, a polling company using random phone numbers might be troublesome because what sort of people answer surveys? What sort of people are willing to answer phone surveys? Maybe there's some bias there. So another type of sampling is non-random sampling. And the most common type of non-random sampling is going to be a convenience sample. Convenience samples are those gathered in some way conveniently. Say, for example, you want to learn about high school students. So if you just survey the high school students in your high school, that's pretty convenient. But it's not a very random sample of all high school students in the world. So the battle between convenience and randomness is always going to be something to be aware of in your research. Most of the time, research is done in universities using the convenience sample of university students, but people will have some sort of argument or description as to why that should generalize to most adults or to at least most college students. If you'd like to learn a little bit more about sampling, random sampling, or different types of samples, feel free to check out this video. I'll link it on this page as well as on the YouTube page this video has been posted on. Okay, so that's it for populations and samples. I hope it makes sense. It's something that's easy to grasp but hard to get all of the little details about. And I hope you've enjoyed this video, and I'll see you, or at least you'll hear me, in the next one.